Okay, so section 9.3, special right triangles. This video is going to be on the first of two types of special right triangles. Um, and then the reason that we call them special is that using the special relationship among the sides will give us exact answers instead of decimal approximations. And in math, we like exact answers um, when possible. Alright, so the first one, which this video is going to be about, is our 45, 45, 90 isosceles right triangle. So here's our right angle. Um, let's review the parts of the right triangle. So let's first start by naming the legs. And anytime throughout this video, if you want to pause and fill in the blanks and then start it again and see if you got it right, feel free to do that. So naming the legs. So we've got legs AC, and we've got leg BC. Alright, and that would only leave the last remaining side to be the hypotenuse. That's going to be AB. And remember, the hypotenuse is always going to be opposite the right angle. Alright, and then since the triangle is isosceles, we know the legs are congruent. Okay, so these legs here are going to be congruent, and that's going to be useful for us soon. Alright, so let's use the property of isosceles triangles to help us find the length of the hypotenuse for a few 45, 45, 90s. And then remember that since it is a right triangle, we can use the Pythagorean theorem. Alright, so we use the Pythagorean theorem to help us. Alright, moving on to our first example here. Let's say side AC is 1. We want to find the lengths of the remaining sides. So if we know that AC is 1, since this is an isosceles right triangle, we know that these two sides are going to be congruent, so this leg will also be 1. And now we want to find the length of AB. So let's use our Pythagorean theorem. We know that AB squared is equal to 1 squared plus 1 squared. So C squared is equal to A squared plus B squared. So AB squared is equal to 1 plus 1, which is 2. So then if I take the square root of both sides, so square root of AB squared here, square root of 2 over here, we end up with AB equals the square root of 2. As you go through the video, if you have any questions, make sure you write them down and then ask me the next time you see me. Alright, next example, given that AC is 2, again, we've got our right angle. We know it's an isosceles triangle, so these legs are going to be congruent. So this side has to be 2 as well, so that leaves us to find the hypotenuse. So again, using the Pythagorean theorem, we have AB squared is equal to 2 squared plus 2 squared. So AB squared is equal to 4 plus 4, which is 8. Take the square root of both sides. Square root of AB squared is equal to the square root of 8. And I know that the square of 8 is the square root of 4 times the square root of 2. If you don't remember how to simplify your radicals, come see me for extra help or go to the point. And that would leave us with AB equals, so the square root of 4 is 2, and then we have the square root of 2 left over. So when the side lengths were 1, the hypotenuse turned out to be the square root of 2. When the side lengths were 2, the hypotenuse turned out to be 2 root 2. So hopefully you're seeing a pattern here. Now let's look at it in general terms. Let's say that AC was x. So we're going to let that be x. Here's my right angle, isosceles triangle, so the legs are going to be congruent. This side's going to be x as well. So now again we need to find the hypotenuse. Let's use the Pythagorean theorem. So I've got AB squared is equal to x squared plus x squared. So AB squared is equal to 2x squared. Take the square root of both sides. Square root of AB squared is equal to the square root of 2x squared. I'm going to separate that to the square root of 2 times the square root of x squared. So we end up with AB is equal to, now this is 2, and that's going to be, or square root of 2, and that's going to be x, so I'm going to take the x and throw it in the front. So we end up with x square root 2. Alright, so when we let the legs be x, we can see the hypotenuse is x root 2. So we're seeing a similar pattern. Legs 1, hypotenuse 1 root 2. Legs 2, hypotenuse 2 root 2. Legs x, hypotenuse x root 2. So let's sum things up down here. Isosceles right triangle conjecture. In an isosceles right triangle, if the legs have length x, then the hypotenuse has length x root 2. So the ratio of the leg to the hypotenuse for the triangle would be 1 to 1 to root 2. Alright, in the next one of the next videos we'll do some practice problems. Again, write down any questions and make sure you ask later.